All right, so yes, I'd like to introduce Rohan Primrose, who is from Equipe Design and Consulting. Alan introduced before. Rohan's been using Creo for about 3 decades, I would say, since 1996, using version 18. So Rohan's been around the Creo or the Pro Engineer world for quite a while. We've worked closely together for a number of years, and yeah, today here we're going to use Rohan's expertise to show us about how this sort of technology is used in the real world. So, Rohan, I might hand over to you.
Thanks, everyone. Pleasure to be presenting today. I am a principal and design consultant for Equipe Design. I've been going for 3 years. Been around the industry for, I came up to Sydney in '98, but worked in some medical, industrial, commercial spaces, from small single party clients all the way up to sort of ResMeds, Cochlears, Nanosonics. Certainly top-down design, and using skeletons. And the style I use is with published geometries and then external copy geometries, to take those references and those CAD geometries from a skeleton, and then down filtering into the parts. That's been my go-to probably since about 2002. The model that example I'll show you today is something I modeled up in, I think it's in Creo 6, and so certainly the capability sort of rings through to what we're using today in Creo 11, and also using older legacy versions of Creo with various different clients. So I thought we'd a couple of things we'd run through, just to so hopefully highlight. Maybe just go back up one screen there, Ben. Just to highlight this example that I model up. I had a bit of spare time for a leap. It was a launch day many moons ago, so apologies if you've seen this one before, but it does highlight the use of those quite well. Can you see my CAD screen, Ben?
No, we can see your PowerPoint, I think.
How do I need to show screen? I will screen monitor 2. Yep, should be able to see it now.
Yes, we can see the mouse. Yep, cool.
So you can see the CAD screen?
Yep, we can.
Yeah, so starting off with the structure of the mouse assembly, we'll run through that. Give you a bit of an overview of the skeleton and what to include and also what not to include. Show you a bit of the published geometries, or pub geoms as I call them, and external copy geoms in action. We'll go through, which is one of the more powerful sides of this top-down design style of modeling, which is the robust flexibility, or the flexible robustness of the CAD architecture. Also talk a little about use of solid bodies. Solid bodies, I think from memory, has come in, it was about 307, 8, something like that, Ben. But you can certainly utilize solid bodies and multi-body modeling in top-down design using published geometries. It just requires a couple of little techniques. Traditionally, as you'll see in the mouse model, when this was done, I constrained myself to only use sort of quilts, curves, datums, axes, to make the skeleton models as light as possible, because there wasn't that multi-body capability, and then those geometries are filtered down through to the parts. and then at the end I'll run through some of the benefits for both small and large design teams, and certainly been fortunate to work at both ends of the scale. So if we're looking on screen now, you can see, and I've always got my model tree open. Another little tip I use just for keeping track of features and references. I've got two columns showing. One's the feature number, which is just the sequential number of features shown in the tree, but the other one is the feature ID. What enables, I think, in the back end, my understanding is the feature ID of this. So if we look at this part line feature, it's number 10 in this model tree, but it's feature ID 285. So that's a unique number, and it's that unique number that allows the reference control going through. So having that in the back of my mind also helps a bit on the troubleshooting side. So you can see, as Ben explained before, the top level mouse assembly, the skeleton resides at the top. Advantage of that is whenever you open up the assembly, it always brings that latest version of the skeleton into session, and so when you regenerate, you've got that latest version driving your geometry. So if you go away for holidays for 2 days, come back, and your design leader has made a change to the skeleton, when you reopen it, it'll do a regeneration, and you'll ensure that you'll have that latest and greatest geometry, layout, and architecture of the model. In this assembly tree, we've got a mixture of parts and assemblies. So here we've got the upper part. We've got a main body, which is showing the sort of top half of the mouse. You've got a wheel, which is a part on its own, and then we've got the mouse lower, and the mouse lower is comprised of two separate assemblies. You got your lower body and then your battery cover at the back, and each of those have the little sort of non-skid, the friction-free pads as mouses or mice usually do. So if we have a look at the architecture from the top, if we open up the skeleton, you can see, certainly as I was saying before, this one's all this is all surfaces and curves. We've also got some axes in there. There's a wheel axis. There's some datum planes, which I use to constrain the curves. But this one set of geometries of all those different features, controls, the entire look, shape, feel, part line interaction, and how the different subcomponents go together. And for what is quite a complex model, if we turn the skeleton on there, of however many features that we've got through all the different parts, all the way down the model tree. It's all controlled by this skeleton, which I think was about 45. Well, there we go, 45 features. So at the top end, that's very light. We've now got terabytes and terabytes of data space, but Creo's certainly very hungry with its sequential saving iterations. When we first started doing this, disk space was a real concern, a bit of RAM and memory side of things as well. So it was really one big advantage is to keep your models as light as possible. On that front, if I open up, say, the upper body part, for what is quite a complex part, I don't think there's a straight edge on this model. I think there was the flavour of Logitech mouse at the time, which was all very organic and curvy because we could. But you can see for quite a complex model, we've got 18 features. And this is, for all intents and purposes, ready to tool, apart from some attachment detail on the inside. So if we go back up to the skeleton, you can see that we've modelled in the complete outside shape. I've also put in some part lines, and so this is putting in at the top level any features that drive interactions between parts, and then that gives me a flexibility to then define those. So part line gaps and having them uniformly, say, set at 1 millimetre the entire way around the product. That's done from the higher level. So now we've got this complete. We're fairly happy with the look and the shape, certainly to start with. How do we get that down to the parts? These used to be, in the old days, scattered anywhere where you created them, and then you had to move them down to the bottom. Now your published geometries, you can see the little arrows heading outwards, are always in the footer, so they're always at the bottom of the model tree, so we know where we can find them. But also, so it captures all of the 3D CAD data and geometries above it. And I organise these out and I bundle them out. So if it's a bit hard to see in the green, maybe if I do an edit definition. So for the upper body, these are the only surfaces that are going to control the shape of that body. And then we've also got some curves which go in there to control part lines. This published geometry, being the upper part, doesn't need to be, I guess, overburdened with any geometry for the bottom of the product, because it's just totally unrelated to this part. Likewise for the bottom, if we've got lower body, if I highlight that, this is just selecting that geometry for those lower body portions. As you can see though, I don't have any feet or any part line or any scallop for the battery in this higher level, and I'll explain the reason for that in a moment. But the general philosophy is trying to push your reference control as low down the model tree as possible, so you're not having to overcomplicate your higher level. Also, from a practical sense, if you've got a team leader with two sub teams working under them, and each sub team is responsible for a sub assembly, and this is a process I implemented at ResMed back in 2003, where we had a humidifier team, which was the front edge of the product, and a flow generator team, which was at the back end. Lead designer controlled the overall shape of how both sub assemblies went together. And then there was a team leader responsible for each of those sub-assemblies, and had a team of engineers working on different parts within those sub-assemblies. They were able to utilize this. So if a member in part, we're looking after the humidifier part, needed to make a change, he could go and see his team leader rather than going to the design lead at the very top, changing it at the very top, and then having everyone who had unrelated parts having to regenerate those their files as well, or their parts as well. So it's really looking to make the most out of the power of top-down design, but also not overburden where it isn't required. An example of that is if we go to our lower body, we can see that there's a lower body skeleton, and so this is a good example. Say this was two team members or two design teams. The top design team doesn't need to know what geometries the feet are, because it's not affecting those parts. And so we can push those, and they're controlled just by a curve. We can push that down to this lower level skeleton, and that lower level skeleton resides in the lower body sub-assembly, so you can see it there. And then looking at this one, I've even got another lower, the battery cover is another level down, and it's also got its own skeleton. Again, having a look at this, so to control the entire level, all the surface geometries are taken from above, a couple of curves for the little feet and the sticky pad. There's a little rib around those are in this skeleton, and including the, let's see, that's his old style, it hasn't sent it to the footer, including the published geometries. This entire skeleton is only 18 features deep. So nice and light, nice and flexible, but also nice and robust. And then if you open up a part, so we'll go all the way down to the bottom, we'll go to a foot part. There's your foot part. I've mirrored these, but we can probably do without doing that. So what is quite a simple part is made up of essentially 4 features if you don't include the data features there, and then that gives us a shape and a depth and a size and all that sort of thing. And so that's sort of an overview of the general architecture of a skeleton and how it sits within the tree structure of each of the sub-assemblies and components. In terms of flexibility and robustness, as always will happen at 5 minutes to midnight, and this has happened in almost every situation, every client or every company I've worked in. You're ready to release parts for prototyping or tooling. 2 days out, marketing come back and say, oh no, this is too big, too small, too wide, too long. You have some engineering test results that come back that require quite a significant design change to geometries. And this is really where the power of top-down design comes into its own. So say for this scenario, we've got the mouse here. We've got it driven from this first defining sketch. It might be a bit hard to see that. You see the green line there. And they said, oh, it's too small in the 90th percentile of users for their hand size. So let's change that to 120. So we see the model grow by 20 mils, barring other geometry falling over and tangent lines dropping off. We have a nice robust model. So that's now increased by 120%. If we go back to the assembly and show the skeleton, we can see the top level skeleton has increased that, but the parts haven't. We'll come down and nervously press the regenerate button or up the top. And so it's now filtering down through the top, regenerating all those parts. Fingers crossed, no red cherry bombs. So with one regeneration, I haven't counted the parts, there's probably 20 parts there. We have now done a significant design change in a matter of less than a minute. The big advantage of this, though, is because we constrained from the top level things like our part line gaps. If we come in here and measure, so we've got a 0.5 mil part line gap, but we can, even though that high level design change, we have that confidence that uniform part line gap is maintained regardless of the geometry that it cuts through. And so that's certainly a big advantage. In confidence, when time's running short and you need to release these files for tooling, having confidence that you have to go and interrogate every iota and every minute facet or detail of your assembly, I just know that my part lines are fine, so I can then go and check for other interactions and do your interference checks and your mass properties and your wall section checks as you should always do. But it gives you confidence that you've got flexible and robust models. Example of this was working for a large multi-international medical company. It had, I don't know, 80 to 100 parts. They needed a size increase in X, Y, and Z by about 115%. We'd been working on it for 6 months, and the regen time to increase the case size was 2.5 hours. And so that gave us real confidence that the architecture of the published geometries down through the top-down design down through the model tree was really robust, and it saved all the screaming from project managers that it was going to be another 3 weeks to get these files out. So we were able to meet the original timeline. So marketing come in and say, well, actually we went a bit over the top. We only want it to be 110 long. We can come back in, change that. you hit regenerate, fingers crossed, and there you go, it's just shortened up again. You will have features like drafts and rounds, which almost would guarantee to fall over it to some extent because they're very constrained by these intersection lines and your tangent lines, which is why I always leave them showing, because I have a just give you a good understanding of where the interactions between those are going to happen. But yeah, certainly it gives us confidence in our models, especially when you get to those pointy ends of the project timeline. Just another couple more points on the theory side before I wrap up. One of the big advantages of this is if you're working, it works with or without Windchill or a data management system. When you need to have different people working on the same geometries but without working on the same assemblies, you don't have to have those assemblies in session, so they won't be bringing the whole assembly into session and then saving over each other, and then it's whoever hits save last wins. Do recommend Windchill and data management systems, but certainly for many organizations aren't quite there yet. So this is a way of managing that. It requires extra thought and thinking, but certainly enables you to do that. In terms of setting up an assembly structure like this, I start with PowerPoint, and I just with orbs, so I assign my part numbers, and I start to really map out, similar to what Ben was showing earlier in the slides, map out the different parts and which ones are going to be in assemblies, which ones are going to be in assemblies with skeletons, so sub-assemblies with sub-assembly skeletons, and map out the parts that way. One advantage is you've got your part numbers assigned with your names to your parts, so when you're creating the parts, it's a copy and paste exercise, but I'm always working with that end goal in mind of what I want this to look like. That being said, though, it's not a set and forget. This is a living CAD file, and I'm constantly going back in to the skeleton and adding new data where two or more features are, or two or more, having geometry where two or more parts are sharing that geometry or interacting with each other through that geometry, similar to that part line example that I showed before. And so you're really looking to try and crystal ball gaze your interactions of your parts. But there are also, once you've created something with a top-down design reference, you can also go and break it later if you need to. So it's not sort of set in stone. It's really a live, fluid model structure. Then you move in and out, up and down, so through the model tree, and certainly having these identifiers of the feature ID numbers certainly helps. And they will be identified when features fall over. It'll say F for this sketch. If it falls over, it'll be F20 and ID 705. So you can then go use your search functions to go and find that. For multi-body modeling, which is certainly I'm using now with a current client, using all solid multi-bodies. The only trick I've found, well, not the only trick, but the real beneficial trick I've found is to put whatever, say you've got three parts, A, B, and C. I will often share all three parts into, say, the part file for part B, just so I've got that awareness of where parts A and C are residing in space. And then one of your features you can put in there is then just a remove body, and then that'll take that out of that's extra solid geometry out of the model session, so your interference checks won't be affected, and your mass properties won't be affected. And also when you go to export your step or your IGES file or your SDL file for a prototype or for a tool, it's not going to have these erroneous bodies just floating in space. So that's, I think, the long and the short of it. Hopefully you've got something out of it. If anyone would like to have any questions, I think Alan or Ben might have an opportunity to do that now, or certainly feel free to reach out and yeah, we can have a chat, see if I can be of some help and bring forward some of the tips and tricks and knowledge that I've been fortunate to accumulate over the last too long a period of time. And also just talking through, I think Ben's just shown up. There is an example of the video I did many moons ago of this mouse on YouTube. My website's there. You can scan the QR code to LinkedIn and access that way. And I've also done a couple of blogs on the website for different methodologies and also how your top-down design philosophy complements your organisational structure of your business. So I hope you found something beneficial and wish you all the best.